Okay, 2 pages. We're now on Unit 2, Matter and Energy. Read the objectives. After studying this unit, you should be able to define matter, list the 3 states in which matter is commonly found, explain the properties of each state of matter, define density, explain the difference between mass and weight, discuss Boyle's law, discuss state Charles' law, discuss the general law of perfect gas, discuss Dalton's law as it relates to the pressure of different gases, define specific gravity and specific volume, explain the law of conservation of energy, state 2 forms of energy important to the HVAC/R industry, explain how heat energy flows between substances at different temperatures, explain how magnetism can be used to convert electrical energy to mechanical energy, describe work and state the formula used to determine the amount of work done by performing a given task, define horsepower, convert horsepower to watts, convert watt hours to British thermal units. Safety checklist. Power-consuming devices have the potential to cause injury. Be sure to de-energize all pumps, motors, and other electrical devices before working on them. When measuring pressures, be sure that your test instruments are fully operational and properly calibrated to avoid possible injury. 2.1. Matter. Matter is commonly defined as a substance that occupies space and has mass. The terms mass and weight are often used interchangeably, but they are not the same. The weight of a substance is the product of the substance's mass and force of gravity pulling down on it. Weight equals mass times gravity. Matter is made up of atoms. Atoms are often described as the smallest amount of a substance and may combine to form molecules. Atoms of one substance may combine chemically with those of another to form a new substance. These new substances are referred to as compounds. The molecules formed cannot be broken down any further without changing the chemical nature of the compound. Matter exists in 3 states: solid, liquids, and gases. The heat content as well as the pressure exerted on matter determine its state. For instance, water is made up of molecules containing atoms of hydrogen and oxygen. 2 atoms of hydrogen and 1 atom of oxygen are in each molecule of water. Figure 2.1. And it says, a water molecule is formed when 2 hydrogen atoms bond with 1 oxygen atom. The chemical formula for water is H2O. Water in the solid state is known as ice. It exerts all of its force downward. When in the solid state, the molecules are highly attracted to each other. Figure 2.2. It says, solids exert all their pressure downward. The molecules of solid water have a great attraction for each other and hold together. When water is heated above its freezing point, it begins to change to a liquid state. The molecular activity is higher, and the water molecules have less attraction for each other. Water in the liquid state exerts a pressure outward and downward. Because water pressure is proportional to its depth, water seeks a level surface where its pressure equals that of the atmosphere above it. Figure 2.3. When water in the container exerts pressure outwards and downward, the outward pressure is what makes water seek its own level. The pressure is proportional to its depth. Water heated above the liquid state, 212 degrees Fahrenheit at standard conditions, becomes a vapor. In the vapor state, the molecules have even less attraction for each other. The vapor exerts pressure evenly in all directions to completely fill the container. Figure 2.4. Gases push in all directions and completely fill the container. In addition to the states of matter, there are other properties of matter that should be discussed to better one's understanding of how different substances react with and compare to each other. 2.2. Mass and weight. Mass is the property of matter that responds to gravitational attraction. Weight is the force that matter, solid, liquid, or gas, applies to a supporting surface when it is at rest. Weight is not a property of matter and is dependent on gravitational attraction. The stronger the force of gravity, the more an object will weigh. The Earth has stronger gravitational attraction forces than the Moon. For this reason, objects weigh more on the Earth than they do on the Moon. All matter has mass. 2.3. Density. The density of a substance describes its mass to volume relationship. The mass contained in a particular volume is the density of that substance. It is often advantageous to compare different substances according to their density, which is expressed in pounds per cubic foot. Water, for example, has the density of 62.4 pounds per cubic foot. Wood floats on water because the density of wood is lower than the density of water. Iron, on the other hand, sinks in water because it is more dense than water. Figure 2.5 lists some typical densities. Using figure 2.5 as a guide, can you figure out why ice floats on water? Substance, aluminum, density per cubic foot, 171. Specific gravity, 2.74. So it asks, can you figure out why ice floats on water? I think it's because its density is less. That has to be the answer. 2.4. Specific gravity. Specific gravity is a unitless number that relates the density of a substance with respect to the density of water. The specific gravity of a substance is calculated by dividing the density of the substance by the density of water, which is 62.4 cubic feet. So, for example, the specific gravity of water is 62.4 cubic feet divided by 62.4 cubic feet, which equals 1. Notice that the units cancel because of the division. The density of red brass is 548 cubic pounds per cubic foot. Its specific gravity is then 548 pounds per cubic foot divided by 62.4 pounds per cubic foot, which equals 8.78. Figure 2.5 lists some typical specific gravities. Figure 2.5 lists some typical specific gravities of substances. Notice that a substance with a specific gravity greater than 1 will sink in water, and a substance with a specific gravity less than 1 will float on water. 2.5. Specific volume. Specific volume refers to the volume that each pound of a gas occupies. The measurement requires that there must be only 1 pound of the gas. Specific volume is expressed in cubic feet per pound, which differs from volume, which is expressed in feet per cubic feet. Period. 1. Okay. We're left on a cliffhanger. Alrighty, that's pages 30 and 31. See you guys tomorrow.